Welcome back. I'm Muggsy, and today I'm going to explain Lewis structures of atoms. The Lewis structure is named after the great American chemist Gilbert Lewis, and it's basically a very simplified diagram of an atom that doesn't show you the nucleus, it doesn't show you the protons, the neutrons, it doesn't even show you all the electrons. It's primarily concerned with just the valence electrons. And the reason for this is valence electrons are the ones that are important when it comes to bonding, both ionic bonding and covalent bonding. So if you don't know how to determine the valence electrons for an atom, I've got a video on that. You should check that out. And also it might help to know how to draw a Bohr model of an atom. I've got a video on that as well. Okay, so assuming you know all that, let's just start with a problem. What is the Lewis diagram of lithium? Well, when making the Lewis diagram of an element, it's really simple. The first thing you do is you just write down the atomic symbol of the element, lithium. The next thing you do is you determine the number of valence electrons in a lithium atom. Now I can look and I can see that lithium is in column 1 of the periodic table. Those are the alkali metals, and all the elements in column 1 of the periodic table have 1 valence electron. So I'm going to place 1 electron around my atomic symbol. Now with a Lewis diagram, you can't just place it willy-nilly. You have to place it basically on the 4 sides of the symbol, as if it were maybe a map. You could place it at north, south, east, and west. It doesn't matter where you place it, so I'll just place my 1 dot on top. It would be fine if I placed my 1 dot over here, or down below, or anywhere. It's just as long as I have 1 dot on one of the 4 sides of that atomic symbol. And that 1 dot represents the 1 valence electron in a lithium atom. I don't care about the 3 total electrons that lithium has. I only care about the 1 valence electron that lithium has. So this is my Lewis structure. You might also hear this called a Lewis diagram or a dot diagram, because we use these little dots for electrons. And in order to really get the hang of this, let's just look at a few more examples. What if I told you to do it for nitrogen? Well, the first thing we would do is we would write down the atomic symbol of nitrogen, which is a big capital N. Then we would look at the periodic table. We would see that nitrogen is in column 15 or 5A, and all the elements in that column have 5 valence electrons. So I'm going to place my 5 valence electrons, 2, 3, 4. I've placed 1 on each of the 4 sides, and then I double up. That's correct. What you can't do when drawing Lewis structures is you can't add multiple dots to one side, something like that, before you fill up all 4 sides. You need to go around and fill up all 4 individually before you start doubling them up. The problem with this one that I just drew is that you're kind of showing that there's one side with no electrons, and that's not really how electrons work, right? Remember, electrons are all negative, so they're repelling each other. So if I just had 2 electrons, they would be on opposite sides, right? And then if I had 4 electrons, they would be spread equally around the nucleus. And then if I had a 5th, I would just double up one of those sides. They wouldn't really be that close to each other in real life, but they wouldn't really be this simple in real life anyway. There's quantum mechanics at play, some very weird stuff. But just remember, when you're drawing your Lewis dot diagram, add 1 to each side before you double them up. Okay, let's look at a different example. What if I had you do fluorine? We can look and we can see that fluorine is in column 7A or 17. Those elements are called the halogens, and they all have 7 valence electrons. So I'm going to draw my F for fluorine, atomic symbol, and I'm going to put 1 electron on each of the 4 sides. That's 4. I need 7, so I have 3 remaining ones. You can just put them wherever you want. It actually doesn't matter which sides you do first. You could have your single electron facing up, you could have it facing down, left, right, doesn't matter. Let's do another example, argon. Argon's a noble gas. It's in column 8A or 18. Therefore, it has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now argon and all the noble gases, you'll notice that this is as many valence electrons as an element can have for our intents and purposes. It's doubled up on each of the four sides. That means it has kind of a full valence electron. Now because of this peculiarity, the noble gases are full, so they don't bond with anything else. We'll learn about bonding further on, but it's important to remember that noble gases are totally full of valence electrons, so they don't need to gain any electrons, they don't need to lose any electrons, they're totally happy the way they are. This comes into play when talking about another noble gas that's a little bit complicated, and that is helium. Now helium, if you look at it, it's in column 8A of the periodic table, so you would expect it to have 8 valence electrons. But as you know, helium only has 2 valence electrons because it only has 2 total electrons. It can't have 8 valence electrons if it only has 2 total electrons. So when drawing the Lewis diagram of helium, you would expect it to look like this. We put 1 dot on each of the 4 sides before we double them up. That's not the case. That would be the case if it was any other element, but for helium, because it's one of these noble gases and its outer orbital is totally full, we draw those 2 electrons next to each other to show that it's full and happy just the way it is. So helium and argon are both noble gases. That's why we both kind of use these double dots to show that they're full. Helium's the only element in the periodic table that we would make this exception for. If we were working with magnesium, for example, which is in column 2 of the periodic table, it has 2 valence electrons, and we put 2 dots next to each other like that, that would actually be the wrong answer. Magnesium does indeed have 2 valence electrons, but you would have to put them on different sides, because remember, you have to put 1 on each of the 4 sides before doubling them up, unless it's helium. Helium is the only exception to this rule. Okay, I think that pretty well covers it. There's maybe one more that I'd like to talk about, and that is, what if I asked you to draw a Lewis structure of iron? Well, you can see iron is a transition metal. It's in the middle of the periodic table. And as I explained in my valence electron video, for the inner transition metals and the transition metals, you can't use this simple column trick of predicting how many valence electrons it will have. I'll have to tell you. And usually, if I'm asking you to draw a Lewis diagram of iron, I'll tell you what the oxidation state of that iron is. So I might say something like, draw me the Lewis diagram of Fe123. Okay, now this is an oxidation state. Oxidation states are written in parentheses, and they're also written in Roman numerals, and they come after an atomic symbol. So Fe3 is telling you that I'm asking you to draw a Lewis structure of iron that has 3 valence electrons. Again, these inner transition metals and transition metals are just very unpredictable, so you wouldn't be able to use the trick that I taught you earlier. You would just kind of need to know the oxidation state. So if I tell you to draw the Lewis diagram of iron 3, you would know it has 3 valence electrons, so I'd go 1, 2, 3, and oops, I think I just screwed up, right? If you've been paying attention, you know exactly what I did. I put 2 on the top before I put 1 on each side. So it should look something like this, 1, 2, 3 with one side open. Okay, I know that was a lot, but this is one of those things that you practice. It's real easy to get down. And then eventually you're going to be drawing Lewis structures of compounds, which is really a lot of fun and really tells you a lot about the molecular geometry of these different compounds. That's more advanced, but you'll get the hang of this real quick, and it's going to lead to all kinds of cool and interesting things. All right, I'll see you next time. And if you want to practice drawing Lewis diagrams, head over to Learnsomething.app, where you can practice this and many other chemistry skills. So for instance, with drawing Lewis diagrams, we give you an element. We ask you to draw a Lewis diagram by placing electrons around it. If you do it incorrectly, then you can actually go through all the steps of how to do it for that specific element. So for boron, it's telling us that boron has 3 valence electrons and place them on each of the 4 sides, okay. And then let's try it again. Okay, so here I have neon. Let's look up neon in the periodic table. I can see it's all the way over there in column 8, so it must have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. As with all Learn Something skills, if you do something that's just kind of wrong, like let's say for carbon here, I'm going to put 2 electrons on top and 2 on the left side before I put them on all 4 sides. We're not going to mark it wrong. We're just going to give you a partial answer and a message. Make sure there's at least 1 electron on each side before adding a second. Okay, so let's go through and do this again. 1, 2, 3, 4, and then submit. Haha, there's the right answer. So as with always, you'll keep practicing until the bar fills all the way up. The elements will get progressively more complicated. And then when you fill the bar all the way up, you'll have demonstrated mastery of this particular skill, drawing Lewis diagrams. So once again, that's Learnsomething.app. Thanks again for watching.